Hello, so today I'm going to give you a short introduction into my PhD project focusing on parasitic infested harbor porpoises and possible adaptations to hypoxia. And as we know, the harbor porpoises in the Baltic and North Seas are heavily affected by increased shipping and noise, fisheries, and pollution, which, as many studies could confirm, can compromise the immune system. Also, accumulating parasitic infestations have been found over the last few decades, especially in the respiratory tract. Damages to the lung may impair tissue function and reduce oxygen uptake, leading to insufficient oxygen supply to high energy and oxygen-consuming organs, such as the heart, brain, and muscle. Ultimately, this may lead to oxidative stress and hypoxia and impair diving ability. It is not known if diseased harbor porpoises are hindered in using their lung volume and suffer from low oxygen conditions, or if they possess compensatory adaptations aiding in staying competitive and viable. To analyze this, I compared the muscle transcriptome of lung-diseased harbor porpoises with those of healthy ones and verified selected candidate genes in a larger subset of samples in a real-time qPCR. I found processes and rate-limiting genes upregulated in anaerobic metabolism, hinting at a higher reliance. The candidate genes are highlighted here in brown. Also, I found lipid metabolism upregulated, and the genes there were not only involved in metabolism, but also had a role in oxidative stress response. Further, I found hints at adaptations in regeneration and myogenic processes, and genes here had a role in mechanical stretch and oxidative stress sensors, and most were heavily involved in maintaining and upholding muscle tissue function. The highest upregulation I found was for a gene indicating proteasomal degradation, though this still could help ensure muscle function by enhancing cell clearance and turnover, which is a vital step in regeneration. I lastly looked into cellular stress responses and identified here genes thought to reverse tissue damages. Many had a role in protection from hypoxia and inflammatory processes, as well as antioxidant production. Interestingly, multiple genes I found upregulated were previously found upregulated in other marine mammals under stress or declining health, hinting at a possible protective function in marine mammals, but this has to be elucidated further. Yes, since this study has limitations, such as a small sample size, more transcriptomes of the muscles and of corresponding lungs will be generated to see if there are compensatory adaptations already in place in the lung. And I will then conduct functional analysis in cell cultures under oxidative stress and hypoxia to test if the selected candidate genes do rescue tissue function and protect from hypoxia. And with this, I'd like to thank my working group at the University of Hamburg and my colleagues at the ETAF in Büsum. Thank you for listening, and if you have questions or want more information, please do approach me.